class in histograms. This is continuing on with your graphing from Fox and Lister. And then when we come back from the field trip on Tuesday, we'll be doing, or after Tuesday, on Wednesday we'll be doing steadily, and we'll be talking about circle graphs. So we're having a whole week of graphing here. All right, so a line plot is a diagram that shows the frequency of data on a number line. You'll remember from, I believe it was either yesterday or Friday's homework or the day before, where they had the little X's above the numbers to show how many people had something, okay? So in this case, what we'll be doing is creating a line plot for Fort Worth's tallest buildings, number of stories, okay? So the number of stories in Fort Worth's tallest buildings. You see you got 20 buildings here, all their stories labeled out. So then what you're going to do for a line plot is simply put a mark at 40. So I'm going to put an X over here at 40 for this building. I had a building at 38. Another one at 40. So you're going to go ahead and graph out and put an X for each of the data points in this set on your number line. And stack those X's up if they double up. Give you a second to do that. All right. So after you get all of your points plotted from Fort Worth's tallest buildings there, you can take a look at your data now and make some observations about it. So one thing that you can look at, and this is in your notes, there is a gap. If you look, I'm sorry, look at the next set of data on your notes. So we've got this line plot here. We're looking at, are there any gaps here? There's hardly any buildings between 20 and 30 stories. They're either lower than 20 or higher than 30. I don't know why that would be, but perhaps if you were someone who was studying the culture of Fort Worth, you might be able to figure that out. Okay. A lot of buildings around the 20-story mark. Okay. 2 buildings are at 40 stories up here. So you've either got the lower end, lower height buildings or really tall buildings. Kind of nothing really in between. What would be interesting would be to find out where in Fort Worth are these buildings located. Are these the ones that are downtown in Fort Worth? Or are these the ones that are downtown and these are kind of out on the interstate somewhere? So these are the kind of things you're going to take a look at your line plot, and you might be able to generate some questions, or you might be able to answer some questions using the line plot. Okay, when you look at your notes on the next little section, it talks about how you can make observations about the distribution of the data that you've plotted. Why are they grouped together in a certain area, or how are they grouped together? And find the mode and the range of the data just based on looking at it.
Yes, I need the phone.
Okay, so when we're looking at this, let's observe this data that's down here on this line plot. You can pick out the number that occurs most often right away, because it's really stacked up here. So the number that occurs most often is the what? What do we call it? Oh, the mode, right. So 52 is the mode here. We have a big gap between 17 and 28, and a big gap between 73 and down here at 62. When we have big gaps where we have one number that's much lower than everything else and one number that's much higher, we call those outliers. Okay, they're separated from the rest of the data by a good space and they're off by themselves. So we call those outlier numbers. And where we see a bunch of data that's been plotted together, we would call that a cluster. Okay? It's a group that's close together. There's one here between 31 and 44. We've got a little cluster of numbers. So when we look at the data on a line plot, we can kind of compare some things answer questions or even use the data to ask questions about what's going on with what we're looking at. Okay? So, we have data here. This is the data on the number of music CDs owned. So let's identify the mode, the range, and outliers based on this data. So what is our mode here? 10. What's the range?
16.
Between 4 and 20. So our range is 16. And then is there an outlier? Or more than one outlier? 20 is an outlier. It's really separated from the rest of this data. I would not call this 4 over here an outlier because it's pretty close to the rest of the data. But 20 is separated out, so I would call 20 an outlier. Okay. Now that's important to know if it's an outlier or not, because if we were doing a scientific experiment, when this 20 out here, we might decide that we don't need that number because it might have been a user error or something. We might have made an error when we were getting that particular point of data. So we might say, okay, 20, that's really weird for it being out there all by itself. Let's exclude that from our results because obviously something happened that wasn't supposed to happen. Okay? All right, a bar graph. Those line graphs, these are bar graphs, and you guys have done these before. It's comparing data using solid bars to represent quantities. So if we were going to make a bar graph out of this set of data here, the cheetah's speed is 70 miles an hour. So what would I do? Plot that, yeah.
You would draw the cheetah, a line above the cheetah all the way to 70.
All the way to 70, right? So I'm going to make the cheetah go all the way to 70. Okay? And make a bar out of that. Then go ahead and plot the rest of these. Now, when you're making a bar graph has spaces in between the bars. When I go to plot the wildebeest here, I'm going to make a space between these two bars. They should not touch a bar graph. Okay? They are completely separate things. Cheetahs and wildebeest are two separate things, so their bars do not touch each other. Okay, so I just quickly sketched in the bars here. Excuse my smartboard pen, it's not the most exact thing in the world, but we've got the cheetah, the wildebeest, the lion, the elk, and the zebra here. So why is a bar graph better for representing this kind of data than a line graph or a line plot would be? Anybody tell me? What do you think, Owen?
So line graph shows like a change over time.
It could. A line plot could show a change over time. But there's one kind of particular reason why we would choose a bar graph instead of a line plot.
A bar graph represents multiple things by a line graph represents one.
That's exactly right. Good job, Joe. Okay. So when we have a bar graph, we've got multiple things here. We've got a cheetah, a wildebeest, a lion, an elk, and a zebra. Are those things all alike? I mean, I know they're all animals, but are they all alike? Are they the same animal? No. Okay, we might do a line plot if we looked at a cheetah and said, when it chased a rabbit, its top speed was 35 miles per hour. And when it chased a wildebeest, its top speed was 70. And when it chased, okay, so then we're comparing the same thing. We have one cheetah, and we're looking at its different miles per hour. We could do a line plot with that. But if we want to compare a cheetah to a wildebeest, we would be better off looking at their top speeds here at miles per hour. We'd be better off looking at a bar graph where we can see one animal next to the other and look at the differences between the two. So bar graph is better because it compares different things. Okay? number of monthly tornadoes that occurred in the U.S. So we're comparing different months here. So we're going to have a bar graph with spaces looking at January through December. And on the left side of our graph is tornadoes. So that's what we're comparing, is tornadoes between the different months. So the common item goes on the left. In the animals over here was their speed. That was the thing that we were looking at when we looked at these different animals. And then the differing items go on the bottom. So over here we're looking at tornadoes all together, and then in the different months, so those items go on the bottom. So which season had the least number of tornadoes? Which month?
January.
January. Okay, so January had the least number of tornadoes. Let's call this which month. It really doesn't define out seasons. Okay, so January had the least, and how do you know that?
Because it's lower than all the other numbers.
Okay, it has the lowest bar, right? All right, and then compare the number of tornadoes that occurred in May and June. How many tornadoes would you say occurred in May? What's that?
In June.
How many occurred in May? So we're comparing May and June. That means what's different between May and June? So about 510, you think, for May? How about June?
About 275.
June, yeah, I'd say close to 275. So May had more tornadoes, right? How many more? Like, if you were going to estimate, about how many more? Huh?
About 225.
Okay, about 225. So about twice as many tornadoes in May than June, right? Okay. About 2 times the number in May. So May was a much more active tornado month during 2004 than June was, although June wasn't too shabby itself, but May had the most. Okay. Now, a special kind of bar graph is called a histogram. And this one uses bars to represent a frequency of numerical data that's been organized in intervals. Okay? So, in the following bar graph, we're looking at a number of animals, again though, that have a speed between 11 and 20 miles per hour. And how many have a speed between 21 and 30? How many between 31 and 40, etc. Okay? So if we look at this bar graph, or histogram actually, if we look at this histogram and this bar graph, what kind of differences do you see between histograms and bar graphs? The bars are connected in histograms. Okay? So bars are connected. In histograms. That's a difference. Okay? What other things do we notice about bar graphs in histograms? Is there anything else that's different or the same? Look closely between the two item types on your paper.
It's all numbers.
What's that?
It's all numbers.
Which one? Like this one has all numbers on both sides, where this one kind of more has categories. Is that what you're saying? That's true. Okay. What's important about these kind of numbers that are on the bottom here?
They describe about the bars.
They do describe about the bars, but there's something different about this set of numbers that say these. They're ranges. Very good. Okay. So on the bottom of the histogram, you're going to have ranges. And you'll notice when you do your ranges on the histograms, where the first range stops, the second range picks up. So 11 to 20, and then 21 to 30. So 20 and 21 are right next to each other. So we put the bar graph touching instead of with a gap, because they're not really two separate items. They're ranges for one kind of thing, and in this case, it's the maximum speed. Okay? So on histograms, we have the bars connected, and we have intervals instead of categories. All right? So what are some things that are the same between the two? Between a bar graph and a string.
They both have bars.
Okay? They both have bars. Okay? And do they both have kind of a quantity out to the left?
Yes.
Okay. Both have a quantity that they're comparing. And which axis would this be?
The X. Y.
Would be the y-axis. And this is the x-axis. Okay? Okay. So if we're going to make a histogram, over here on the next example, number 6, we've got magnitudes of earthquakes. And which one is the interval here on this table graph that we got?
Wonderful.
What are we going to put on the x-axis? What are we going to put on the y-axis?
Magnitude.
Magnitude will go where?
X.
X. So magnitude will be on the x. It has the interval. So that means frequency is going to go on
Y.
the y-axis. I'll just put those labels out there. Okay. Do we have to start at 0 on the x-axis for this kind of a graph? No, we don't. We can just start with our first interval, which is 7.0 to 7.4. Okay, so we can label out our intervals. And I'm just going to do 3 of them here. And then our frequency starts at 1. And on our frequency, do we have to start at 0 on our should we start at 0 on our frequency?
Yeah.
We probably should. We've got a number down here close to 1. Most of the time on your y-axis, you're going to want to count in a pattern, 5, 10, 15, 20, 1, 2, 3, 4, 5, 2, 4, 6, 8, something like that. In fact, I am just going to, since we're going up to 14, and it's got a kind of short line here, I am going to go 2, 4, 6, 8. And then you're going to go ahead and draw in your bars, and you're going to make them touch for each interval. So the interval of 7.0 to 7.4 with a frequency of 4, we'll get a bar that goes over to 4. And when you're coloring in your bars, do you want to color them all the same color? You want to make sure there's something different about each one so you can tell where one starts and one stops, just in case you have 2 bars that are equal. So for 7.5 to 7.9, we would go all the way to 14 and just attach on to that first bar. And then keep adding along. Okay. Any questions about histogram? There's one more example here of a histogram that shows the stores in the largest malls in the U.S. And you'll notice we also have tables at the bottom. If we're going to interpret this, how many malls are represented total in the histogram? How many malls are there that we're comparing?
14. Or 5. 5. Wait.
Take a look. How would you figure that out?
30.
And how did you figure that out?
Plus all the numbers. Okay.
Right, you're going to add 10 malls have this many stores. 14 have this many. Okay, so that's a total of 24 so far. Plus another 4, plus 1, plus 4. Okay, so 30 malls. You're looking at your frequency numbers and adding up your frequencies to figure out how many total there are. Then how many malls have less than 200 stores? 10. That falls in this range down here. So we have 10. And how many have 200 or more? 20. That's right, 20. So all of them that are left have 200